Hi everyone, welcome back to our YouTube channel Set Education. In our previous video, we have taken the example of this array and we tried to sort using selection sort, and we have done a very quickest way in which we can solve the selection sort. We have seen that way, right? Now in this video, I'm going to actually tell how it follows the algorithm, what all comparisons we do. For example, in our previous example, if someone asked me how many number of comparison we made, I might not able to give it, though I can tell you that we can compare it easily if you understand it, but that's okay. So in this video, we are going to see actually how in-depth selection sort works, right? So stay tuned to this video, and if you like this video, please do like, share, and subscribe. Thank you. Yeah, so let's get started. So if you see, this is an array we have 92, 36, 14, 2, 18, and 62. So what I'll do, I'll write this 36, 14, 2, 18, 62. So how I get started is, first I will consider my first element as minimum, and then I'm going to iterate through my entire list of array and figure it out element which any least element present in the array, and I'm going to swap it with the first element. So what I'll do is I'm considering this as 92 as minimum. Again, consider this 92 not as the element value, consider it as an index value. So it is easy to swap the index values. Okay. So 92 is my minimum. Okay. If I find any element which is less than 92, I will update my minimum, and I'm keep doing that in the same way. Okay. So 92 is my minimum. Now if you compare, 92 is greater than 36 means I have got a least element than 92, so my minimum will be updated to 36. Now minimum is 36, and it will keep 36 will be my minimum. Again, if I figure it out any least element than 36, I will change my minimum. So here 14. So do you think 14 is less than 36? Yes. So my minimum will be updated. Now, my minimum is 14. So 14 is greater than 2. So my minimum gets updated. Now 2 is less than 18. So my minimum remains 2. Now 2 is less than 62 also. So my minimum remains 2. So what I do, whatever is the minimum, I basically what I do is I swap this minimum with the my first element. So swap minimum with first element with first element. So your minimum here is what? Is 2, and your first element is 92. So you swap these two. So if you swap it, what you will get? So if you swap 92 and you swap 2, what you will get? You will get 2, 92, others remains same, 18, 62. So this is my first iteration. Okay. Now let's get started with the second iteration. So I don't need to consider this. This is sorted. Now I will start with second element and I'll say this as minimum. Now if this is minimum, I got 14. 36 is greater than 14 means I have the least available. So I will change my minimum to 14. Now my 14 will be the minimum, and 14 is less than 92. So 14 remains the minimum. 14 is also less than 18. So 14 remains the minimum. 14 is also less than 62. So my minimum remains 14. So my minimum here was 14, and my second element, because I'm in the second iteration, was 36. So I need to swap these guys. So if you swap 36 with 14, you will get 2, 14, 36, and others remain same. Now in third iteration, again what we'll do, we get started with the third element. So I will say this is minimum. So 36 is less than 92, so minimum remains same, 36. 36 is greater than 18, so my minimum gets updated, and 18 is less than 62, so my minimum remains 18 here. So my minimum at the end was 18, and I was in the third iteration, so my third element is 36. What I need to do, I need to swap these two. So if you swap 36 and 18, so you will get what? 2, 14, 18, 92, 36, 62. Right? Now quickly get started with we are done with the third iteration, fourth element. So I will say this is minimum. So 36 is less than 92, so my minimum will update to 36, and we'll follow this until and unless we get the least element than 36. So again 62 is there, which is not the least, so 36 is my minimum. So I got minimum as 36, and my fourth element is 92. So what you need to do, you need to swap. So 92 with 36. Okay, so let's quickly do that. 2, 14, 18, 36, 92, 62. Then let's quickly do for the fifth element. So I will call this as minimum. So 92 is greater than 62. So I have this minimum. So my minimum changed to 62. So you have minimum at the end of the array 62, and your fifth element was 92. So you need to swap. So when you swap it, what you get? You get 2, 14, 18, 36, 62, 92. So if you check, you have only the single element left, and we stop it here because you don't have it, right? So this is the sorted array. If you see, we have done the sorted array. So this is how actually the selection sort algorithm works. Now, if you carefully see and if you want to drive the algorithm, you can see two important observations from this example, right? The first observation is what we are doing. We are first starting with first element, saying that as minimum, then starting with second element, then starting with third element, then fourth element, then fifth element, and at the end we have left with the one element. So we need one for loop to get started with this minimum and iterate through the entire list. So if you see, we need one element from I equal to, if it is from 0, it has to go to n minus 2. Anyone can tell me why n minus 2? Because here we need to stop. If we have n elements, so we should have n minus 1 iteration, right? N minus 1 iteration. So that's what. So if you have if you're starting from 0 index, you need to do how many iteration? N minus 2. If you have confusion, you can write from 1 and then you can write n minus 1, not a problem for me. Okay. Now, second observation is then what we are doing, one we are considering. So one loop is okay for you. And other loop is you are then again checking these values, right? From here, from first element, right? Then you are checking all the comparison here. Then you are doing all the comparison here. Okay. Then you are comparing all here. And then you're comparing all from here. Sorry, not here, from here, right? Means you need one more for loop, which is starting from, I plus 1 to n minus 1, and you are comparing. You are comparing. After comparing, what you are doing? At the end, you are swapping. At the end, you are swapping. Right? At the end, you are swapping. So you need to swap. So you need to swap. So this is how the rough algorithm of selection sort look like. So in case you get the idea how the selection sort works, I just wanted to show you and give you a feel that there is nothing complex involved. It's just you need to understand, right? So in our next video, we are going to write actual algorithm, and then we are going to drive time complexity and space complexity from that. And then we are going to take some more quick examples for your understanding. So if you like this video, please do like, share, and subscribe. Thank you.